Greetings and welcome to my new calculus channel. My name is John Gabriel. So, how did the notion of angle in geometry come about? So, well, if you do a search for it on Google, you'll get a lot of answers. And one of the answers says that the first concept, angle as a quality, was used by Evdemus of Rhodes or Rhodos, who regarded an angle as a deviation from a straight line. The second, angle as a quality by Carpus of Antioch, who regarded it as the interval or space between the intersecting lines, and Euclid adopted the third, angle as a relationship. So I'm not terribly sure of Evdamos and Carpus, so I'm not going to argue about that, but let me show you how, in my mind, I thought about the concept. So first of all, but before I do that, let me show you how Euclid thought about the concept. So in his definition, he says that a plane angle is the inclination of the lines to one another. Okay, so when two lines in a plane meet one another and are not lying in a straight line. So what he was saying is that you have a plane. So let's say this is a plane, and you have two lines, and they have an inclination to each other. But now, how would you understand the word inclination, and what gives us the clue from the Greek? Well, it's very simple. This word over here, klisis, grammon klisis, or line inclination. Okay, so, well, again, how do you know what that inclination is, and how would Euclid have recognized it? Okay, so there are a number of possible ways. Let's look at a few. So again, um, first of all, the fourth requirement says all right angles are equal, and I'll get to that in a moment. But if you're going to talk about angles as inclines, then you need a way of measuring that incline, right? So, for example, you need to position these two rays according to a frame of reference, right? So you'd have a frame of reference, and then one line of the angle like that, and the other one coinciding with one of the lines. And now you have a frame of reference. Now you can actually say what the incline of this line is to the x-axis. It's simply this length over this length, right? So immediately there you have gradients. So, there's some people who say that the Greeks didn't know about rise over run. Well, that's absolute rubbish. Of course they did. And in that particular uh, definition, in the elements, okay, that's what it says. It says that the relationship is the inclination. So, and how can you know that the angle is the same if even if those two lines are extended? How can you know that? Well, there are several ways to think about this. The more complicated way is to say, well, let's consider the radius length to the radius, okay? Because it doesn't matter what angle you have, by the way. Even if you have an angle that looks like that, you can measure all these three angles by simply putting each of the vertices at this point. So to measure this one, you would do something like this, right? Something like that, okay? And you would measure that angle which corresponds to that one. And then similarly, you do the same with the other two sides. So that is the way that one way that you might do it, but it's a complicated way because it's hard to measure this distance. Even the ancients didn't find it easy. Okay, so but there is a simpler way to do this, and one of the ways to do this is to start by having a right angle. Okay, so let's say that the right angle is that particular angle, which is formed by one of the equal arcs of a circle when it is divided twice. In other words, when it is divided once with one diameter and again with another diameter, so that all the arcs are equal. Now, in my book called there are no axioms or postulates in mathematics. I explain how this is all derived from nothing and that there is no such thing as an axiom or a postulate in Greek mathematics. Okay, so you start off with a right angle, and again, you don't have to use this complicated fact of the quarter arc to the radius. You could say very simply that this here is a right angle isosceles triangle, isn't it? Okay, so now you could move away from the circle entirely. You could do this, this, and this, where this is a right angle, right? And then measure every one of these angles, by taking, let's see, by taking this distance, over the entire distance of the hypotenuse. And of course, the Greeks knew the distance of the hypotenuse. What was it? That's right. It was this distance here was known as root 2, or simply just the failed measure, that is recognized, from hypotenuse to side, So this ratio is equal to this failed measure, which is approximately 1.414. Okay, so that is what they decided to use as a basis for angle measure. So initially, it started off as just a concept of an angle in a plane, and then of course it developed, and the Greeks had some. In fact, the Elements has another complicated, well, not complicated, but a more advanced proposition, where it talks about proving this. Let's just get a pen. So it talks about proving that the area of a square inscribed in a circle is in proportion. But you don't need all this, do you, when you have the scheme that I just showed you here? And of course, this is a scheme that I used in the recent revelation I posted a video about, and you all know about that. It's the radical unit measure, which does not rely on circle geometry. Well, with one exception, it relies on the fact that you have a right angle. Okay, and so why did the Greeks say that all right angles are equal? Because they wanted to make sure that regardless of which circle you use, the measure would be the same. Okay, so if you had like an angle there, let's do this. So if you had an angle there like this, in this particular instance, it would be this length over the whole length, right? And if you made the circle of any different size, like this, then it would be this length over this whole length. So all those ratios are in proportion. But get this, all their measure is the same. It's the same failed measure, this 1.414. Okay, so basically that is how you got the concept of angles. So without further ado, you'll read a lot of stuff on the internet, most of it wrong, and what I've given you is correct. If you're not already a subscriber to my channel, become one. Click like, because I have a lot of enemies and they will obviously vote my videos down. Also become a follower on Academia, to which I'll place a link. Tell your friends about my channel, and I'll also include a link to donations so that you can donate to my channel. My name is John Gabriel. This is the New Calculus channel. Till next time, goodbye.